Okay, we're going to be solving equations, graphing, and I'm actually going to be talking about factoring as well here, because keep in mind that we're going to, when we talk about solving, where does it cross the x-axis? And so this is why we dealt with radicals. We're going to be doing square roots. We're going to be looking at the quadratic formula. And we're going to be looking at factoring as well. So first of all, keep in mind, let's do this. So I could be a parabola and I could cross, right? 2 times, right? Could I be a parabola and cross the x-axis once? Sure. I could be sitting right on it. Could I be a parabola and not cross the x-axis at all? Absolutely, if I hang out above or if I hang out below. Okay, so we're going to talk about how you can get no real solutions. So there would be none here. There would be 1 solution, or there would be 2 real solutions. Okay, so let's do the first one. X squared plus 2x is equal to 3. So the first thing I'm going to do is I'm going to move that 3 over on the other side and set it equal to 0. So I'm going to graph this because that's one of the methods, and I'll kind of show you and then give you an option, because you know I like to work smarter, not harder. This is in standard form, right? So negative b over 2a. Let's see, this would be negative 2 over 2, which is a negative 1. So my axis of symmetry is here. And let's see, when I plug negative 1 in, I get 1 minus 2 minus 3, which would be a negative 4. 1, 2, 3, 4. And my c is negative 3, so I come up here and here, and then okay, so well, I am just kind of looking here. I don't really know if this is correct. I'm hoping that this is where it crosses, but wouldn't it be nice if I actually knew where it crossed? Well, let me show you a method that you learned. I know you know how to factor. 1 is plus, 1 is minus. Factors of 3 that subtract to give you 2. Well, one of them is 3 and one of them is 1. But my answer really isn't a positive 3. It's really a negative 3. And it's not a negative 1, it's a positive 1. So look, I should have had my graph go through here and here, right? Okay, so which method do you think was probably a better hit? Absolutely. This actually was a much better secure, okay? Now, you know, there are other examples where you can do it and we get to see. So for example, x squared minus 8x equals a negative 16. So the first thing I would do is I'd add 16 to both sides. Okay, I'll graph this again. Negative 8 over 2 is 4. Okay, and if I plug that back in, 4 squared is 16 minus 32 plus 16 equals 0. 0 equals 0. Oh, so I'm right here. So that means I must be sitting right on the x-axis. Up 1 over 1 for my slope, because my slope is 1. So I'm sitting. So here, my solution is 4, 0. So graphing was fine. But do you see how you could have factored this just as easy? 4 and 4. But it's not really a negative 4, it's a positive 4. Okay, so let's try this one. Negative x squared equals 2x plus 4. All right, let's see. You know what? I'm going to move this over here by adding x squared. So 0 equals x squared plus 2x plus 4. And I'm going to go ahead and I'm going to try to graph it. Let's see. Negative 2 over 2 times 1, so that's a negative 1. All right, I'm going to plug that back in, and I get 1 minus 2 plus 4 is, let's see, 5 would be 3. Negative 1, 1, 2, 3. And looks like my y-intercept is 4. What I do to one side? Oh. I don't even cross the x-axis, do I? So there would be none. What? Okay, now wait a second. Could we have factored that? Well, yeah, 2 and 2, right? Oh, but 2 and 2 don't give you 2 in the center. So you can't get this not factorable. Now, there will be a way that we can come up with the answers to this. They'll just be imaginary, okay? So remember that looking at any sort of function, whether it be all you have to look for is where it crosses the x-axis. So my solutions here would be negative 4, negative 1, 2, 4, and 5. Now, 1, 2, 3, 4, 5. That's probably something to the 5th power. It is okay. You can also work at approximating zeros using your calculator if you needed to, where you can kind of look at, for example, they have you in here x squared plus 4x plus 1, and if you hit graph, you can see it doesn't quite go through where you want it to. So what you might want to do instead, can you see that all right? Kind of looks like a little, so go to your second function graph, your table, and instead see how it goes 0, 1. It said to hit second function window and change your table to be 0.1. Now, it's kind of a pain, but if you go to 0.1, you might be able to get a better, so look, see how it went from positive to negative? So somewhere between there, so negative 2 something something, okay? That's your change of signs, is where you can tell where it goes. So your your solution is closest to negative 0.11, and let's look over here. Oop. to keep going because it's going to come back up. Oh, there we go. See it? It's coming back up right there. See how it went from negative 3.7 to 0.24. So you could approximate your zeros as well. Okay, thanks.